Hello guys, good evening. Can you hear me all? Hello Gurman, how are you? Hello Shitish. Hi Muskan. So have you finished your assignment? I can see some of you have still not joined. Okay, so we'll just wait for them for a few minutes. Okay. Hello Aro, have you finished your assignment, all of you guys? Please tell me what is the status of assignment? Yes, all the assignments actually. No, all the PDFs plus the assignments on Learnist. All whatever I have given till now in nomenclature. How many of you have finished? Okay, if you won't reply, I have to take your name then. Okay, Oro is almost done. How many of you have finished 50%? I can see Anusha, what is your status? Arya, Mriganka, tell me your status regarding the homework. Okay, Pradyun, Rubhav, fine, 50%. Okay, Shitish, 80, Arya, half, 50%. Tell me, by next class, will you finish that? Pakka, right? Fine. So all of you must finish your homework. Whatever we are giving you, it's not about the subject, chemistry, physics, maths. Whatever homework you are getting, just do it, finish it. Okay, don't let them, get pile up. Otherwise, you won't get time later. Okay, so please understand that. Especially those who are looking for exams like KVPY. Okay, you have to start, you know, study organic chemistry. That's why I have taken nomenclature first this year. Okay, so that you can start a little bit on your own. Anyways, okay, so we'll discuss all these things later. Okay, today we are going to start a new chapter, the first chapter of physical chemistry, and the name is some basic concepts of chemistry. How many of you have been gone through the folder I have shared, the Google Drive folder I have shared? Did you see those books? Oro, not yet. Why, Oro? You didn't get time? Okay, see, the reason is we understand nowadays you are not going out. Okay, there's no communication from outside, and we are going with our syllabus, right? We are moving forward with our syllabus. Okay, so the thing is, you must have some book for practice. Okay, to study or some practice. Okay, that's why we have shared those books. Okay, so for any practice and study or any reference, if you want to take, you can take the reference of those books. Okay, now you do not need to open that inorganic chemistry book and organic chemistry book, right? If you want to solve some more questions on nomenclature, then you can go through that organic chemistry book I have shared, right? You can solve some questions from that book also. Okay, today we are starting physical chemistry, some basic concepts, so you can solve those questions of physical chemistry, the first chapter which is given over there. Okay, for practice you can solve those. Okay guys, fine, so give me just 1 minute, I'll take some water and we'll start. Okay, so anybody has any idea what are we going to study in this chapter? Could you see the screen now? Great. Yeah. Okay. Mole concept. Yeah. Mole concept and some basic concepts are the same thing. Okay. In some book, it is written mole concept. In some book, you have written basic concepts. So we are going to start today some basic concepts of chemistry. Okay. Now, in this chapter, this is the first chapter of your physical chemistry. Okay. And in this chapter, you are going to have numerical problems. Okay. Like in organic, the first chapter we have done, in that chapter you do not have numericals, right? Just you have little rules, theory. Based on that, you will have questions, right? You just have to name them. Here we deals with here we deals with uh, you know chemical reactions, their properties, right? The amounts of product we get in a reaction. How do we find out the amount of product that is forming? Okay, what are atoms? What are molecules? Right, atomic mass, relative atomic mass. Okay, concept of mole, stoichiometry. We'll discuss about stoichiometry. That's nothing but the amount of product. Okay, empirical molecular formula we'll see, and we also talk about the different concentration terms here. Right, so guys, this chapter we are going to study in two different portions, which is not given in the book. I used to have this kind of uh, curriculum for this chapter. I teach this chapter in two different parts. Okay, and we call it as mole concept 1, and mole concept 2. Okay, in two different parts we'll discuss it, right? We'll study. So mole concept 1, like I said, will study about the different atoms, molecules, moles, all those things we'll discuss here, right? Mole concept 2 will discuss about the concept of equivalence, right? Here we mainly discuss about the concepts of equivalence. This is the design I have done for this chapter, okay, which helps you in understanding concept and further the exams that you are going to write. Okay, so we'll discuss about concepts of equivalence, which is required to understand the equivalent weight. Have you heard about it? Equivalent weight. And then normality. Have you heard about normality? Equivalent weight normality. Have you heard about formality? And this formality is not that English word formality. It's different. In chemistry, have you heard about formality in chemistry? No. Correct. Okay. So basically, these three things we have to understand. Actually, the purpose of us of this thing is to understand this normality, right? Normality is a concentration term. Okay, I'll discuss this in detail. I'm just giving you a brief overview of the chapter. Okay, normality is a concentration term. Now you must have heard about molarity, molality. Yes or no? Quickly typing. Molarity, molality. You must have heard, right? Okay, Kshitiz did not hear about it. Okay, I guess most of you have heard about it. Okay, so some of you have this idea that there are, excuse me, two concentration term, that is molarity and molality. Okay, no problem, no problem. If you haven't heard, we'll do all these discussion just a second. Okay, so some of you have this idea that there are two concentration term, molarity and molality. Similarly, normality is also a concentration term. But to understand normality, you must have the concept of equivalence. So that's why here we'll discuss the concentration term, means molarity and molality. We'll discuss it here. And then we'll move on to the mole concept too. We'll discuss about the concepts of equivalence, equivalent weight and all. And then we'll see normality. Correct? So basically, to understand the third concentration term here, which is the normality, we are going to study concepts of equivalence and equivalent weight also. Correct? So this is how the chapter is designed. Okay, and that is what we are going to study in this chapter. Okay, so first part we are going to start here, and that is the mole concept 1. Okay, mole concept 1. Okay, okay, guys. So in chemistry, we are going to deals with, first of all, we are going to deals with chemical compounds. Correct? Chemical compounds. In the entire chemistry, we only talk about the chemical compounds. What is a chemical compound? Any example? Any example of chemical compounds? NaCl, HCl, H2SO4, there are many, right? Like you said, NaCl, HCl, we can take NaOH, right? We can take, for example, H2SO4. We can take example like CH3COOH, etc. Many examples we have. Okay. Now, what are these compounds actually? NaCl, HCl. This is a salt. This is an acid. This is a base. This is also an acid. And this is also an acid. This is also an acid. The difference between these two acids and this acid is the below one, this one, is a weak acid. and these two are strong acid. This is strong, this is also strong acid. Similarly, NaOH is a strong base, and we can also have some weak bases also, like NH4OH. Okay, so these are the various chemical compounds we have. Chemical compounds can be anything, can be salt, can be acid, can be base, can be anything, right? Now, how these chemical compounds are made up of? If you see all these compounds, like suppose if I'm taking an example of, you know, NaCl, right? So NaCl is made up of two atoms. One is sodium and other one is chlorine, right? One is sodium and other one is chlorine. HCl again made up of two atoms, hydrogen and chlorine. NaOH, Na, oxygen and hydrogen, three atoms. Similarly, we have H2SO4 and acid, CH3COOH, correct? So here we are using a term, and that is an atom. Means compounds basically are made up of atoms. So first of all, what is an atom, right? So an atom is what? Atom is, how do you define an atom of any element? How do you define an atom of any element? Any one of you? The smallest unit which retains all the property. The smallest indivisible part of an element. Mriganka, you said the smallest part of a substance which may or may not take part in a chemical reaction. Okay. Then what does take part in a chemical reaction? If not atom, then what takes part in a chemical reaction? Defining structure of an element, okay? Defining structure of an element. That is another new thing. Okay. Okay. Definition of atom is what? Atom is the smallest part of an element, right? Atom is the smallest part of an element, okay? But if you write down till here, like smallest part of an element, it is wrong, right? I see some of you have already said this, that it is the smallest part of an element, right? Now you see the Priyam is saying smallest unit of an element which is indivisible and may or may not have independent existence, but always takes part in a chemical reaction. Oh my God. Okay. Can we divide an atom? Yes or no? Have you heard about subatomic particles? Right? Yes. So what does it mean? The subatomic particles, yeah, correct. Electrons, protons. So subatomic particles present within an atom. Yes, can I say that? Subatomic particles can present within the atom. It means subatomic particles are smaller than the atom. Can we say that? Because if it is not small, it won't get fit within an atom, right? Correct? Subatomic particles are obviously smaller than the atoms, right? And that is why we cannot say atom is the smallest particle. Is it clear? All of you, right? Atoms are not the smallest particle, correct? Because there are particles, subatomic particles, which is present within the atom. So obviously atom cannot be the smallest particle. So when you say it is the smallest particle which has an independent existence, that is not correct, right? But if you say like this, atom is the smallest particle which takes part in a chemical reaction, then that is correct, right? Because chemical reactions generally will talk about the normal chemical reactions in which the chemical substance are involved, not redox reaction, correct? So when you say it is the like the atoms are the smallest particle which takes part in a chemical reaction, then it is correct. The definition of an atom, all of you write down. It is the smallest part of an element which takes part in a chemical reaction, right? The smallest part of an element which takes part in the chemical reaction, right? For example, what we can write, the example is we can take oxygen atom, we can take nitrogen, we can take hydrogen, etc. Anyone. All these are the examples of an atom, right? The atom of hydrogen, write down. The atom of hydrogen is the lightest and smallest out of all the known elements. Hydrogen is the lightest and smallest atom we have, right? Now next point you write down, all atom does not occur free in nature, all atom does not occur free in nature, but they combines with each other, and forms another kind of substance. They combines with each other and forms another kind of substance, which is known as molecules. Okay, any doubt? No, He is not smallest. Hydrogen is the smallest we have. Yeah, I'll repeat. Wait. All atom, all atom does not occur free in nature, all atom does not occur free in nature, comma, some of the atoms, some of the atoms have tendency some of the atoms have tendency to combine with each other combines with each other and forms molecules. Okay, combines with each other and forms molecules. No, it's not. Helium is not the smallest one. It's the helium, or the noble gas has this thing, van der Waals forces, right? That's why they have the size of the noble gases are higher than the other elements in the same period. We'll discuss about, yes, you are right. If you go from left to right in a periodic table, the size decreases, correct? That's what you're talking about, Kshitish. Yes, yes. In fact, in a given period, the noble gas has the highest, the largest size actually, because of van der Waals radius. Okay, we'll discuss all these things later. Okay, let's not go there. Okay, let us understand this thing, what I'm trying to make you understand. Okay, so atoms, hydrogen is the smallest and like lightest unit. There are some atoms which does not occur in free state. Like for example, helium exists as He only. Okay, so if you look at this, helium exists as He only, correct? But hydrogen exists as H2. Okay, what does it mean? If you look at this, the point that I just now I've given you is, like I said, there are some atoms which does not occur free in nature, which means what? If you talk about the oxygen gas, oxygen exists as what? Look at this. Oxygen exists as O2 molecule, right? It is a molecule. Oxygen, this one is a molecule, not an atom, because we have two oxygen atoms here. Similarly, nitrogen exists as what? Exists as N2 molecule. Yeah, ozone also we can say it is O3. Right? But if you talk about helium, right? Helium exists as He only. Right? So this one has independent existence, right? Helium or any noble gas has independent existence, but oxygen atom is not that stable, or we can say the condition, the normal temperature that we have, in that the two oxygen molecules combines and forms, two oxygen atom combines and forms one oxygen molecule. Okay, now the bonding of oxygen molecule, if you see, okay, it has a double bond between the two oxygen atom. I am not going into detail of all these, why oxygen atom has one double bond present here, that I am not going to discuss here. We'll discuss that later in other chapter. Okay, see, actually what happens, we are going to take some reference of few things which we are going to study in the coming chapter. Okay, so we'll discuss those things later. Okay, basically by chemical bonding, if you discuss from that chapter, all these things will get clear, how the bond formation takes place. So when you talk about the oxygen molecule exists as this. Have you done Lewis dot structure? There's a double bond between the two oxygen atom, and each oxygen atom has two lone pair present on it. Do you understand what is a lone pair of electron? Yes, Lewis dot structure, you know. Do you understand what is a lone pair of electron? Yes, correct. All of you understood what is the lone pair of electron? Quickly you reply, guys. Otherwise, I'll move on. Okay, I want this session to be both way. Okay, I don't want to talk alone. Yes, Ruba. We'll discuss that. We'll discuss that. Yeah, that's why I'm asking you it again and again. Right? If you do not know anything, just stop me. Don't let me go like this. Okay? Otherwise, you will feel difficulty. One more thing, guys, I would like you to understand here. This chapter is something which we are going to use in various other chapters which are coming in this 11th standard, even in 12th standard also. If you have confusion over here, you won't get those concepts clear in the other chapter, right? So that's why this is very important for you to understand, right? Now you see lone pair means what. I'll take one example and make you understand. Okay, what is a lone pair of electron? Okay, in detail I am not going, like I have already said. We just take some reference and try to make you understand, correct? Just take all these things as it is. Okay, 2 3 chapters if you do, right, by the end of chemical bonding you will get to know all these things. You'll get the concepts properly. So lone pair I will explain over here. Suppose I am taking an example of water molecule, right? And I guess all of you know the formula of water, that is H2O. Water molecule has this shape, right? It is this. It is not linear. This is not the shape of water molecule. You know this fact? Quickly. The shape of water molecule is this bent type shape, V shape. It's not linear. Okay. So now you have to consider the shape also. You should know the shape and geometry of the molecule, right? In this 11th grade. So you see here, first of all, this I'll just remove it off. Water molecule, you see each bond, we understand that in each bond there is one pair of electron present. Okay, again, Oro, we can discuss this thing. Okay, why the shape is like this, everything we can discuss. But to understand this, Oro, you should know hybridization. Do you know hybridization? No. You even do not know VSEPR theory, valence shell electron pair repulsion theory. Correct? So that's why I said in the beginning, some reference we are taking now. Just take this as it is. All these concepts we are going to discuss in chemical bonding chapter. Got it, Oro? So you have to give me some time to make you understand all these things. Okay? We are not concerned about how the shape is this. Why not we have other shape over here? Right? We are not concerned about it, but we are trying to understand some point over here. So as we are just taking the reference of this. Okay, so take this as it is. Let me finish 1 or 2 or 3 chapters like till chemical bonding. After that you can come out, reach out to me anytime, right? Why the shape is this, hybridization is this. We'll discuss everything then. Okay, but I'm sure when we finish that you won't have much doubt. Okay, so just bear with me for few days. Okay, let me finish these chapters, then we'll get back to this if you have still any confusion, right? The point is here, we have oxygen water molecule like this, and in this, again, this information I'm giving you, the two oxygen molecule has two pair of electron present over here like this. Okay, so we have actually two types of electron pair here. When you talk about a bond here, right, each bond contains two electrons. These white dots that you have here, these are the electrons of oxygen, and this dot is the electrons of hydrogen atom, suppose I'm taking, right? So these electron pair which is present between the oxygen and hydrogen, we call it as bond pair of electron. This is also bond pair of electron. And the electron pair which is present on the central atom is oxygen here. these two electron pairs present on the central atom, and these electron pairs which is present over there, we call it as lone pair of electron. And this lone is not that bank wala lone. Okay, it's LONE, it's not LOAN. Okay, so keep that in mind. Did you get it, guys? Understood what is lone pair of electron, what is bond pair of electron? Lone pair of electron, the electron pair which is present on the atom, like this one. Right here, the bond pair that we have, two electron here, two electron here, are the bond pair of electron, shared pair of electron. Correct. So this is one thing. Now this part you let it be. Okay, this lone pair bond pair, let it be, not required. Now here I'm talking about molecule. So oxygen atom does not exist as in its atomic form. Means we won't get at normal temperature and condition, we won't get oxygen atom present like this. It always exists in this form. Okay, why? Because there are bonding takes place between the two oxygen atom, right? Bonding takes place between the two oxygen atom because the condition is there, the normal condition is like that, so that the two oxygen atom combines together and forms a molecule, right? Now again, this is the concept of bonding, so I'm not going into detail of all this. Just you have to keep in mind that at normal temperature, normal condition, oxygen atom does not exist, but this atom exists in the form of molecule, which is O2 molecule. The same thing have for nitrogen, but nitrogen atom has three bonds between the two nitrogen atom like this. It has a triple bond and one lone pair on each nitrogen atom like this. Clear? Okay. Now, one extra information I'm giving you here, which is not actually required in this chapter. This bond forms by the overlapping of orbitals. Orbitals is something in which the electron is present. Okay, you can consider orbital as like, you are there in your house, correct? So if the house is an atom, right, you yourself, you consider yourself as an electron, then the room in which you are sitting in now, that room is the orbital for you. Did you get it? Orbital, you are an electron, the room is the orbital, and the entire house is what? It is an atom. Did you get it? So electron always present in the orbital. No, orbit orbital is not the same thing. Actually, there's nothing called orbit. The concept of orbit was is actually wrong. Not completely, but it is wrong. Okay, why this is wrong, we'll discuss this in again atomic structure next chapter that we have here, right? Orbit is something which is the spherical in shape, right? You must have studied this in 10th grade, that electron present in the orbit and revolves around the nucleus. Yes or no, guys? Electron present in the orbit revolves around the nucleus in a circular path, right, Anusha? In a circular path, correct? But the point is, around the nucleus, the path may or may not be circular. That you do not know. Okay, around the nucleus, the path may or may not be circular. Okay, that you do not know. All those paths, what kinds of path we have? We can have a circular path. We can have a path like this. We can have a path like this also. Or not like this. Just a second. Circular is possible. Dumbbell shape is possible, right? We can have a path like this. Double dumbbell we call it as. I'll just show you. Double dumbbell is like this. We have this and then this. All these paths possible within an atom, right? These are the orbitals, right? Yes, dumbbell shape, double dumbbell shape, spherical shape. So when you talk about orbit, the concept of orbit was right till here only. Like I said, the path may or may not be circular. For these kind of things, the orbit concept is not true. Yes, SPD Arshit is very good. We'll discuss all those things. Okay. So here what happens, the orbit, there is nothing called orbit, but actually we have orbital. What is an orbital? Orbital is the space, three-dimensional space or volume where the electron presents or resides within an atom. Okay, the best example I have given you, the room where you are sitting in, that room is your orbital if you consider yourself as an electron, and the entire house becomes what? Atom. Correct? So this is one thing. Now this thing here, what happens? Oxygen has electron present. So two oxygen atom combines together, right, and forms a bond, right? This combination requires certain condition. If that condition is not there, the combination is not possible. Correct? So for combination, or for the combination of two atoms, we require certain condition. You must have seen few reactions, like suppose A and B give C, right? And there are some reaction condition written over here. Temperature this, catalyst we are using this, solvent we are using this. These you must have seen this kind of reaction, right? A reaction takes place at some condition. Suppose I have written here A plus B gives C, and temperature is around, we have here 80 degrees Celsius, right? This kind of reaction you must have seen. Some catalyst is present here, iron and some other catalyst present here. Have you seen this kind of reaction? Some pressure also maintained. Some suppose 4 atmospheric pressure also maintained. What all these things are? These things are the reaction condition. Means this reaction takes place at this condition. So point I'm trying to make is what? That for any reaction, for any combination, we must have certain condition, right? If that condition is not there, combination is not possible. Reaction is not possible. Have you ever seen, suppose you have a burning candle, right? Burning candle, and when you covered this with a glass, what happens then? Completely, if you cover this completely with a glass, what happens after some time? Extinguished. Why it happens? Why it happens? Out of O2. Very good. So the reaction condition is what? Yes. So reaction condition is what? Could you tell me what is the reaction condition here? Presence of O2. Correct. So that is the combustion reaction, right? Combustion reaction is what? We require oxygen for that reaction to possible. Correct. So this means what? For any reaction, we must have that essential condition must present over there. If that is not there, the reaction is not possible. Am I clear with this? All of you, are you getting me? Yes, right. So here also what happens, the same thing we have here, oxygen at the room temperature. We have oxygen in the atmosphere, correct? We have oxygen in the atmosphere. So we have helium also present, right? But helium and helium atoms are not combining and forms He2. Helium exists as what? He only. Helium does not exist as He2. This is not possible for helium, right? But O2 possible, N2 possible. Because why? Because the atmospheric condition that we have here to combine two helium atom is not sufficient. That is why helium is not forming as a molecule, like existing as a molecule, He2, correct? But O2 and N2 exist, right? So this is what, for condition is sufficient for O2 and N2, so it exists. One thing. Another thing is what? That, this is the structure we have here, right? One more example we can take. If you try to understand this, wood burns in presence of air. You must, have studied the combustion reaction, right? Reaction of wood in presence of oxygen, combustion reaction, right? Now, could you tell me, wherever you are sitting in, around yourself, is there oxygen present? Yes, obviously it is. Lot, correct? Wood is present around you, any in the form of, like, almirah, in the form of bed, or chair or anything. Wood is also present. Why this wood does not react with the, hello, am I audible, Anusha? Guys, please respond. Am I audible? Anusha is not getting me. Am I audible? Yes, Anusha, it's fine now. Yeah, okay, fine. So my question is, there are oxygens, a lot of oxygen present around you, and there is wood also present in different forms around you. Why these wood does not react with the atmospheric oxygen which is present and gives the combustion reaction? Yes, very good. Because the ignition temperature is required. We must have that minimum energy or temperature for that reaction to possible. Yes, very good, Pradyum. The ambient temperature is not enough. That is the same thing we have here. Why helium does not exist as He2, but oxygen, nitrogen does exist. Okay. The condition is not sufficient for two helium atoms to combine together and forms a helium molecule. I hope this is clear now to all of you. Correct? So there are atoms, right? Definition of atoms we have seen. Now these atoms combines, there are some atoms combines together to forms molecule, right? So based on the number of molecules, the number of atoms present in the molecules are classified into three different categories. Am I clear? The molecules are classified into three different categories. That is monoatomic, diatomic, and polyatomic molecules. Okay, I'm coming to this point. Just wait for a second. One more thing I would like you to understand here. You see, there are two at bond present between the two oxygen atom in a molecule, right? Okay. So one of the bond here is the sigma bond, and another bond is the pi bond. This I have discussed, right? In a in a triple bond, one sigma and two pi. In a double bond, one sigma and one pi. In a single bond, there is only one sigma. Yes, I have discussed this in organic first class, right? Now you see the two oxygen atom here. Can you see me now? My video is on. I hope you can see me. All of you, yeah. So you see this two oxygen atom we have, right? And when these two oxygen atom combines like this, okay, you consider this as the oxygen atom combines like this, so we'll have a sigma bond here between the two atoms. We have a sigma bond here, right? Now this oxygen nucleus that you have here, well, with this only there are orbitals present like this, perpendicular direction. The orbitals present like this in perpendicular direction. Okay, one orbital in this direction which overlaps like this and forms a sigma bond. The other orbital is present in perpendicular direction. Suppose if this orbital is along the x-axis, so this is along the y-axis, correct? So this x-axis orbital overlaps and forms a sigma bond like this. Okay. Now this orbital which are perpendicular, right? This also has tendency to overlap with each other and forms a pi bond. So if you look at this, this is the overlap of orbital, right? This is the overlap and this is the overlap. And this kind of overlap takes place like this. If I can show you, this is along the x-axis, just a rough diagram to make you understand. Along the x-axis, this forms a sigma bond here, and when these two overlaps, this forms a pi bond. It's not like one pi bond this side, one pi bond this side. It's not like that. These two collectively gives one pi bond. Okay, so if you see the structure of a pi bond, this is suppose the sigma bond we have. So pi bond means what? Above this and below this, we have an electron cloud. Okay, I'm using this technical term. Don't get confused over here, right? This is the electron cloud we have. Means overlapping of orbital takes place. Here we have orbital, here we have orbital. These two overlaps and forms an electron cloud like this. These two electron clouds collectively gives one pi bond. Is it clear? Triple bond is also like this. We have one more orbital present here. We have one more orbital present here. These two forms one pi. Again, when these overlaps, gives you one more bond. That is triple bond. How many of you get it? I know it is a dumbbell shape because it is a p orbital. It is a p sharp shell. That's why it is a dumbbell shape. So again, yes, it is a bit confusing at this stage. So don't get worried, right? If you are getting confused, it is actually good because you haven't done all this stuff before. But I can assure you one thing, just bear with me 1 month, 1 or 2 months, we'll discuss all these things in detail, right? So some of you have asked me, how do you know it is a dumbbell shape? I know it is a dumbbell shape because it is the electrons of oxygen and nitrogen present in P subshell. And P subshell means it is a dumbbell shape. If you have D subshell, it is a double dumbbell shape, right? So I am just repeating it again. However, if you are not getting it, don't worry about it, right? We'll discuss all these things in coming chapter, right? So what happens here, I said that the sigma bond forms by the axial overlapping. You see, this is the nucleus actually. You understand this. This is the two atom, oxygen atom, and this is the nucleus of this, right? So when the orbital overlaps along the nucleus, it always forms a sigma bond. Axial overlapping we call it as, correct? And the other orbitals are fixed like this in y direction. So this overlap is lateral overlapping, correct? Lateral overlapping gives you pi bond, right? Axial overlapping gives you always sigma bond. So what happens here, this sigma bond forms by axial overlap of orbital, and this pi bond forms when this orbital and this orbital overlaps like this, then pi bond forms. Did you get it? 50%. How many of you understood this? 50% at least. Arya, tell me. Okay, could you give me the percentage, like 50% I understood, 60%, 100%, 90%, like that. 50 also, if you understood, it's fine. Okay, let it be for now. Okay, we'll discuss this later. Right, I can understand there will be some confusion. It's very natural because you haven't done this before. Right, so we'll do all these things easily. 65.4, Sitish is very precise. Very good, Sitish. Anyways, so let us, no, okay, let's move forward for this, okay? So what I was talking about molecules. So write down the line over there, one note you write down. Um, on the basis of, on the basis of the number of atoms present in the molecule, on the basis of the number of atoms present in the molecules are classified into, the molecules are classified into three categories. Three categories. First one, write down all of you. Monoatomic. These are the molecules which contains only one atom. Molecules which contains only one atom. Example, write down. Yes, it is. Yes, it is. For this case, atoms and molecules are same. But since we are classifying it, right, we cannot directly say, okay, we have diatomic molecules. Okay, we cannot say we have polyatomic molecules directly, right? So you can say in this case, atoms and molecules are the same thing. Okay, but this is how it is done. Since it is done on the basis of the number of atoms present, so we have one atom, what we call it as, when two atom, what we call it as, more than two, what we call it as. Okay, so in this case, it is nothing but an atom. Okay, fine. Monoatomic, write down the first example here. It is all inert gas you can take, the examples of it. Helium we can take, neon we can take, argon, etc. You know what we call it as? These gases? Which group it is in periodic table? Which group it is in periodic table, guys? Noble gas, group 18, right? We call it as noble gas, group 18. Why we call it as noble gas or inert gas? Hardly react. They do not form any compounds. No, we call it as inert gas because they do not react easily. That is the reason. That's why they are inert, noble. Do they form any compound? Any example have you come across? Any example, any compounds of noble gas? XCF8. XCF is not there, guys. Gurman, it is XCF2. You can have XCF4. You can have XTO2F2, right? But you see, in all these noble gases, there is only one, you know, there's only one element, which is xenon, which forms compounds. Okay, xenon is the only atom of noble gas which forms compounds. Yes, XCF6 also possible, right? Other noble gas does not form compounds here. Okay, next, write down next diatomic molecule. Write down diatomic molecules. These are the molecules which has two atoms, which has two atoms present. Molecules which has two atoms present in it. For example, we can have H2, we can have O2, we can have N2, we can have X2. X2 is what? X2 is the halogen, means F2, Cl2, Br2, I2, etc. Right? All those molecules are diatomic molecules. No, it's not like that, Anusha. It is usually in atmosphere how does these atom exist, whether they exist as monatomic molecules, diatomic molecules, or poly. Naturally, how they exist based on that only it is. Okay, fine. The third one you write down. Third one is polyatomic. Polyatomic molecules. Write down, these are the molecules which has more than two atoms present. Okay, they are the molecules which has two or more atoms, sorry, more than two atoms present in it. Okay, so for example, we can have phosphorus, P4, we can have S8. All these are examples. We have not very important. P4, S8 are the examples of polyatomic molecules. Finished? Correct. So basically what we can say, the all these discussion we have done so far, right? Basically we can say we have atoms first of all, right? With this atoms, we get what? We get molecules. And when we combine two or more molecules, you'll get compounds. Okay? So we have atoms first. With atoms, we'll get molecules. Compound molecules, you'll get compounds. Okay? The basic, the thing is atom only for all these. Molecules basically contains two or more atoms. Two or more atoms. Compounds, it contains two or more molecules. No, for metals we have a different chapter here, right? For metals we have a different chapter, that is we'll have D and F block elements that we'll do in grade 12. Little bit we'll discuss about metals in a chapter called periodic properties. That is the other chapter we have, not in this one. Okay. Now, the another thing is, one more term we are going to understand here. Have you ever heard about a term that is this isotope? What is an isotope? Same atomic number, but different mass number, correct? Yeah. So write down the heading. Yeah, got it, got it. Write down the heading, the definition here. These are the different atoms of same elements. These are different atoms of same element which has equal atomic number, but different mass number. Equal atomic number but different mass number. Okay, now the symbol that we use here to explain this is, suppose we have any elements, we have E, right? And then we'll write here A and we'll write here Z, right? This A stands for here the mass number, and this Z stands for the atomic number, right? Mass number is nothing but the number of protons plus neutrons. Atomic number is what? It is the number of protons. So could you tell me, with respect to this A and Z, what is the number of neutrons? number of neutrons, if you see, that would be equals to A minus Z. Correct. A minus Z is the number of neutrons. Fine. So this is one thing, first of all. Okay. Now, if we write this example, suppose we have 1H1, we have 2H1, 3H1. Okay. For all these elements, you see, these are the different atoms of same element. These are the atoms of the element that is hydrogen. Okay. This we call it as protium. The first one is protium. The second one is deuterium. And the third one is tritium. Okay. This is also represented by protium is H simply. This is T and this is D. Right? So this is the three things. Now for all these three atoms, you see the atomic number is same. 1, 1, and 1. Right? There's the atomic number 1, 1, and 1. But the mass number is different 1, 2, 3. Right? So these are the isotopes of each other. Correct? Isotopes of each other. Now we can also define isotope in one different way, and that is if you count the number of neutrons for these three atoms, if you count the number of neutrons, for protium, the number of neutrons is 0. For deuterium, the number of neutrons is 1. And for tritium, the number of neutrons is 2. Correct. So we can also define isotopes in this way, that these are the different atoms of same elements which has same number of protons but different number of neutrons. Okay, so what we can define, we can also define this as these are the different atoms of same element which has equal number of protons but different number of neutrons. Any doubt, you can ask me. If not, then you can type CLR. Correct. Okay. The another term we have isobar. Have you studied about this isobar? Okay, write down the definition here. These are the atoms of different element. Atoms of different element which has the same mass number, which has the same mass number. Correct? For example, we can write C14, carbon 14 and nitrogen 14. C14 and N14, correct? So for this one also you try to understand here, different elements means what? You see here, atoms of different elements. Different elements, if you say, it means they must have different number of protons, right? So we can also define this as these are the atoms which has different atomic number but same mass number. Different atomic number but same mass number. Example we have already seen, C14 and CN14. There is one more term, we call it as isotone. These are the atoms of different element with same mass number. Atoms of different element with same not oh sorry with same number of protons actually. Atoms of different element with same number of neutrons. So again you see, atoms of different elements means different atomic number, and that further means different number of protons. Okay, example. B12 and C13. Could you tell me the number of neutrons for these two elements? Number of neutrons. Okay, I got your response, Shitish. Others, please tell me the number of neutrons here. No, Priyam. Yes, correct, Muskan. Priyam, that's wrong. Tell me the correct one. Yeah, that's right, Priyam. Okay, so boron, the atomic number of boron is 5. Mass number is 12. So its number of neutron is 7. For this also 13 minus 6 atomic number of neutrons is 7. Clear? Okay. Definition you must remember, important. Now we have discussed that atoms do combine with each other and forms molecule. No, just definition you should keep in mind. Nothing is special. Okay. Okay. Now the atoms, one thing you can also keep that in mind here, that about deuterium you write down. Have you heard about D2O type molecules? D2O, like H2O, we have D2O also. This we call it as heavy water. Heavy water used in nuclear reactor it is. Yes, heavy water used in nuclear reactor. That is the only one thing you should keep in mind, nothing much. Okay. Next, write down that we know this fact that atoms combines together and forms molecules. Correct? Molecules. So what are the rules or law we have through which atom combines together and forms molecules? Okay. This we call it as law of chemical combination. Law of chemical combination. The first thing is, or the first law is law of conservation of mass. Just a second. Okay. Law of conservation of mass, write down into this. In a chemical change or chemical reaction, in a chemical change or chemical reaction, the total mass remains conserved. Okay. The total mass remains conserved. Okay. So what do we understand by this? You see here, suppose we have a reaction in which the mass of reactant is given, right? So what we can write here, according to this law, that the mass of reactant is equals to the mass of product. Okay, mass of reactant is equals to the mass of product. But this relation is true. This relation is true only when the reaction is complete. So for complete reaction, okay. Now complete reaction means what? The reactant converts into product 100% conversion we have. Okay, all reactants converts into product. Into product means there is no unreacted reactant, no residue left, or residue means unreacted reactant. Is it clear? There is one more relation here, which is based on the same law. It's actually the same thing. We are just conserving the mass. Mass of reactant is equals to the mass of product plus the mass of unreacted reactant. Right? So this relation is true when the reaction is incomplete. For incomplete reaction. Incomplete reaction. Reaction in which when some unreacted reactant is left, in that case we can write down this. Done? Fine? Correct. Now based on this, could you solve this question? The question is, what mass of sodium chloride would be sodium chloride would be decomposed by 9.8 gram of sulfuric acid if 12 gram of sodium bisulfate 0.75 gram of HCl were produced in the reaction. Find out this. All of you must write down the question first and then you start solving this. Okay, Muskan, that's not correct. Ansh, Oro, Arabi, Anusha. It's correct. Muskan, check your calculation once. Correct, Priyam. Right, Gurman. See, the question is what? Could you tell me the formula of sodium bisulfate? Okay. It's not Na2SO4, but it's NaHSO4. Na2SO4 is sodium sulfate. Priyam, if you write Na2, then it should be SO4, not HSO4. See, here what happens, the reaction is this NaCl plus H2SO4. It forms what? NaHSO4. Sodium bisulfate plus HCl. Okay. Now everything is given. It says 12 gram of sodium bisulfate forms and 2.75 gram of HCl forms, and the mass that combines with 9.8 gram of H2SO4. This mass I am assuming as M, which we need to find out. So according to the law of conservation of mass, total amount of reactant is equals to the total amount of product. So it forms what? 4.95 gram. This is the answer for this question. Any doubt? Anyone? Just you need to conserve the mass, that is it. Clear. Okay. The second law of conservation you write down. Law of constant proportion. Write down the definition. A chemical compound A chemical compound has a fixed composition by mass. A chemical compound has fixed composition by mass and it does not depend on and it does not depend on the method of its preparation and it does not depend upon the method of its preparation or the source from which it is obtained. Right? Again, I am repeating, all of you copy this. A chemical compound has a fixed composition by mass and it does not depend on the method of its preparation or the source from which it has been obtained. Okay. Now, what is the meaning of this? That we'll see. I'll take one simple example here to make you understand. And that is, suppose I am taking CO2. CO2 can be prepared by different methods, right? One of the methods I'm showing you here. If you have carbon and carbon combines with excess of oxygen, it forms CO2, right? CO2 can also be obtained by heating its carbonates, CaCO3. When you heat this, it forms CaO solid plus CO2 gas, right? Now, according to this law, what happens? All compounds has fixed composition by its mass. It means what? Whenever CO2 is there, right? Carbon dioxide, CO2 is there. The mass of oxygen is what in this compound? Could you tell me what is the mass of oxygen here? It's 32, right? 32 AMU you can say, 32 gram you can say, 32 AMU or gram, anything you can say. Okay, for carbon it is 12 gram, right? Now this 12 gram and 32 gram, it says what? The carbon and oxygen, the mass ratio is fixed, which is 12 is to 32. Whenever it forms carbon CO2, sorry, CO2 molecules, its ratio will be, carbon and oxygen ratio will be 3 is to 8 only. No matter what is the preparation method of carbon dioxide we have. That is what the law of constant proportion we have. Okay. Now one note we have into this, that note you write down. The converse of this law is not true. Right. The converse of this law is not true. It depends upon the different experimenting condition.
It depends upon the different experimental condition. Okay. Now, what does it mean? You see this. Suppose the compound is not given and the ratio of carbon, hydrogen, and oxygen is given. That is 12 is to 3 is to 8. Could you tell me what is the possible compound we have here? What is the possible compound we have here? If the ratio of carbon, hydrogen, and oxygen is 12 is to 3 is to 8, mass ratio is this. No, it's not. Yes, Anusha, that's right. One possible thing is that. Any other structure we have? Okay. So one possible structure is this. The molecular formula could be this C2H6O. You see, with this molecular formula, the ratio of mass of carbon, hydrogen, and oxygen is 12 is to 3 is to 8 only. Correct? No doubt. Okay. Yeah. But with this formula, we can, what is the possible structure of this molecule? Could you tell me again? What is the name of the compound? That's what I'm asking Oishik. What is the possible formula of this? Ethanol, Kshitish. Kshitish, what is the DOU for ethanol? Could you tell me? Yes, DBE. Okay, Gurman is getting ethanol. Is it right? Ethanol is a, okay. So DBE is 0. If DBE is 0 for this molecule, it means you cannot draw aldehyde or ketone. Correct, Anusha? Yes. So that's why, could you tell me the possible structure of this molecule? Yes, Anshan Gurman is correct. Yeah, right, Shitish. Okay. So the possible structure of this is, we can draw the two possible structure here. One is correctly you said, that is CH3 CH2 OH. Another structure, if you see, that we can draw is CH3O CH3. What is the name of this compound. Can you tell me what is the IUPAC name of the two compound? What is the IUPAC name of the two compound? Is it methyl methanoate? No, it's not. Ansh. Or what is the answer? Dimethyl ether is not the IUPAC name. It's common name. Methoxymethane is correct. Okay. So the first one is ethanol and the second one is methoxymethane. Okay. Why don't you revise this? Okay. Do revise all these formulas, all these rules. So this molecule is an ethanol, but this one is methoxymethane. Okay. So you see what point I'm trying to make here is, if the ratio is given, then with the same ratio, we can have two different molecules possible, right? But if molecule is given, then two different ratio is not possible, right? That is what this means, that the converse of this law is not true. Once you know the molecule, their mass ratio will be fixed. You cannot change that. But if the mass ratio is given, then we cannot predict the exact structure or exact structure of the molecules. And that is what it means. The law of constant proportion, the converse of this law is not true. Is it clear? Any doubt? Correct. Now the third law we have here is the law of multiple proportion. Law of multiple proportion. Write down a statement here. If two elements if two elements combines to form more than one compound, if two elements combines to form more than one compound, okay, then the different masses of one element, then the different masses of one element which combines with then the different masses of one element which combines with a fixed mass of other element, okay, fixed mass of other element, comma, bears a simple ratio to one another. Bears a simple ratio to one another. Again, I am repeating this. If two elements combines to form more than one compound, right? Then the different masses of one element which combines with a fixed mass of other element bears a simple ratio to one another. That is the law of multiple proportion we have. For example, you see, if hydrogen and oxygen combines, so when hydrogen and oxygen combines, H and O, they form two different compounds. One is H2O and other one is H2O2. Okay, if you see here, the mass of hydrogen and oxygen in both compound, for hydrogen it is 2 gram, oxygen is 16 gram. Here also if you check, hydrogen is 2 gram, oxygen is 32 gram. Okay, so when you look at this, oh sorry, hydrogen is 2 gram here. So when you look at this, same mass of hydrogen combines with oxygen, combines with different mass of oxygen to give different compounds. Correct? So same mass combines with two different mass of the same element. This is the law of multiple proportion. And when you check the ratio of oxygen in the two compound, the mass of oxygen in the two compound, that ratio is should be a simple ratio. So if you find out the ratio here, you'll get 1:2, the ratio. That is what it means, that it bears a simple ratio with each other. This is law of multiple proportion. Okay. Third one you write down, fourth one you write down, law of gaseous volume. One more we have after this, and then we'll see some questions on this. Write down. This we also call it Gay-Lussac law. Okay. Write down. The gases reacts with each other. The gases reacts with each other in the simple ratio the gases reacts with each other in the simple ratio of their volumes the simple ratio of their volumes at a given temperature and pressure. At a given temperature and pressure. Okay, comma, and if the product is also in gaseous state, and if the product is also in gaseous state, then the volume of product also bears a simple ratio with the volume of the reactant molecule. also bears a simple ratio with the volume of the reactant molecules. Did you write this? Should I repeat it again? Tell me, guys. Yeah, yeah, wait. Write down. According to this law, the gas reacts with each other in the simple ratio of their volumes. In the simple ratio of their volumes. Just a second, guys, just a second. Yeah, okay. I'm sorry, guys. Yeah. I'm repeating it again. Gas reacts with each other in the simple ratio of their volumes. And if the in the simple ratio of their volumes at a given temperature and pressure, and if the product is also in gaseous state, and if the product is also in the gaseous state, the volume of the product the volume of the product also bears a simple ratio with the volume of the reactant molecules. Done? Wait. Did you write down the statement? All of you finished? Correct. So you see, this law is true at constant temperature and pressure. Temperature and pressure must be constant for this law. Correct. Now, according to this law, right, the gas reacts with each other in the simple ratio of their volume, gaseous product only. Means we can only compare the gaseous product and gaseous reactant. For example, if I write down this equation, this reaction, H2 H2 gas combines with Cl2 gas and gives 2HCl gas. This is what I am taking. First of all, the reaction should be balanced for this comparison. Here the reaction is balanced. You see this 1 mole, because we have 1 over here. So 1 combines with 1 of Cl2 and forms 2 moles of HCl, right? So what we can say here is moles and volumes we can compare easily, and what we can say is 1 volume of H2 combines with 1 volume of Cl2 and gives 2 volume of HCl. This we can only compare for gaseous species, right? If there any solid or liquid forms it is there, then we cannot talk about that. Okay, for example, if you are taking H2 gas plus O2 gas gives 2H2O liquid, and if you balance this it becomes this equation, right? So what we can say here, 2 volume of H2 combines with 1 volume of O2, and we cannot write here gives 2 volume of H2O. This we cannot write, since this the H2O that is written over here is not in gaseous state, but this is in liquid state. Okay, so we can only compare the volume of gaseous species. That also we can say the ratio must be same. It is the simplest ratio, Anusha. You can also say 2 moles of H2 combines with 2 moles of Cl2 and gives 4 moles of HCl. That also you can say. With 2 and 2 moles of H2 and Cl2, HCl should be 4 moles then, not 2. Yes, it is. It only works for gaseous species. Two moles of hydrogen atom. Just a second, we'll explain. You are saying, Anusha, you are saying 2 moles of hydrogen. So for that, if you want to say 2 moles, you should have here 2H2. Then we can say 2 moles. But if you write down 2H2 here, the reaction is not balanced then. Then you have to balance the reaction first, and then we can compare. Is it, Anusha, you're talking about? Anusha, I'm not getting you. You do one thing, you can unmute yourself and talk. Probably I can understand then.
So it's 2 moles of the hydrogen atom, not the molecule.
Oh, you are saying hydrogen atom we have. We have H2 molecule we have, no? It's not hydrogen atom, we have H2 molecule. So we can say here, one molecule of H2, okay, I understood your concern. One molecule of H2 combines with one molecule of Cl2. And what is the volume of one molecule of H2? It is one volume of that. So one volume of H2 molecule combines with one volume of Cl2 molecules and gives 2 volume of HCl. Is it fine now? Correct. Okay. This law works only for gaseous reaction because we are comparing the moles and volume here actually. and we have a relation called PV is equals to nRT. You know this relation? Right. So we'll discuss this reaction in this relation in as gaseous state. But one thing I'll tell you here, P is the pressure, V is the volume, T is the temperature, N is the number of moles, and R is the gaseous constant. Okay, and this relation holds true for ideal gas, perfect gas. Okay, so now you see if the pressure and temperature is constant, R is already a constant, then V is directly proportional to N, and this relation is true only for gas. So this relation that we have written here, volume and number of moles are directly proportional, and that's why we are saying here one volume of this, one volume of this gives this. It is because of this relation only. And since this relation is true for gas, hence this law is also true only for gas. Is it clear? Correct. So that is the reason we have. Now, based on this, we'll see one question here, one problem we'll see. Write down the question. How much volume of oxygen will be required? Volume of oxygen will be required for complete combustion of for complete combustion of 40 ml of acetylene and how much volume of CO2 will be formed at NTP. NTP is the normal temperature and pressure. You don't have to worry about it. Whenever STP and NTP written, it means the temperature and pressure is constant. That is what it means here. But at NTP, the temperature value is 20 degrees Celsius and pressure is 1 atmospheric. The purpose of this thing given here, NTP, it means the temperature and pressure is constant. Now find out this. Done. Okay, Arabi, it's correct. Very good. Acetylene is C2H2. Those who do not know, acetylene is ethine, C2H2. Correct, Arya. Very good. Okay. First of all, what we do, we'll write down the balanced chemical reaction for this particular question. So the question is what? We have acetylene, that is C2H2, and the combustion of it, right? C2H2 gas, combustion of this means reaction with O2 gas, and it forms CO2 gas plus water liquid. This is what the reaction we have. Correct? So this law, we know it is applied only for gaseous state, right? So this, we don't have to do anything with this water liquid here. Now, first of all, we will balance the reaction. So when you balance this, you'll get 2, 5, 4, and 2 moles here. Now this means what? Since the temperature and pressure is constant, this means 2 volume of this reacts with 5 volume of this and gives 4 volume of CO2. This is what it means, right? Now, what is the question? The question is 40 ml of this, right? 40 ml of acetylene means we are taking 40 ml. So for 40 to get here 40, what we need to do? We need to just solve this for 40 volume. What happens, right? So if you multiply this by 20, 20 into 2, this becomes 100 and this becomes 80 ml, ml, and ml. Means 40 ml of this requires 100 ml of oxygen and gives 80 ml of carbon dioxide in this reaction. Clear? Easy? No doubt. Okay. Next, write down the last law we have, and that is the law of reciprocal proportion. Write down into this. Write down when definite mass of an element of, sorry, write down like this. When the definite mass of an element A combines with, write down like this, element A in bracket. Element A. Just a second, guys. First, you understand this, and then I'll dictate you the law over here, right? So just you wait, hold on for 2 minutes. Let me explain this. What is this law? This means that suppose we have hydrogen, correct? Hydrogen I am taking, and this hydrogen suppose combines with two different elements, and that I am taking Na and Cl. When hydrogen combines with Na, it forms NaH. Combines with Cl, it forms HCl. Okay. So if you find out the mass ratio here, in NaH, the mass of sodium is 23 gram, and hydrogen is 1 gram, and this is 1 gram hydrogen, and Cl is 35.5 gram. So what this law suggests, that the mass, when one element combines with two different elements with equal mass, then the two different elements, when they combines, means what? Here when Na and Cl combines, it forms NaCl. It forms NaCl, right? And the ratio of mass of Na and Cl, right, will be in the same proportion as we have in this compound. The mass of Na we have here, the mass of Cl we have here, will have the same proportion here, and that is what we are getting here. In NaCl, we have 23 is to 35.5 gram mass proportion. Correct? Now you write down the statement of it. When definite mass of one element A when definite mass of one element A combines with two other elements B and C, combines with two other elements B and C to form two compounds, to form two compounds, comma, then B and C also combines in the same ratio in the same proportion, you write down, not ratio. Then B and C also combines in the same proportion by mass to form a compound. Okay, to form a compound. However, you know one thing, this law is not true for all the molecules. Like it does not hold true with H2O and H2S. Right? It is just a special case we have. It found to be correct for some of the molecules. Right? For example, if you talk about this one, H2O and H2S, the mass of hydrogen is 2 gram here. The mass of hydrogen is 2 gram here. This means when sulfur and oxygen combines, they form SO2. So their mass ratio should also be in this ratio. 16 is to 32. It should be like this. But here the mass of sulfur is 32 and mass of oxygen is also 32. So you see, it is not in the same ratio. It should be 16 is to 32, which is not the case, right? Even with SO3 also it forms. You have 32 and 48. So here the ratio is 2 is to 3, which is not again true, right? So point is, this law is a special case. It is observed to be correct for some of the molecules, not for all the molecules, right? So it is a special case of a more general law, we can say, right? Which is the mass of, which is the law of multiple proportion. It is the special case of that, you can say. Since it is observed for few molecules, that's why they have given this a different name, law of reciprocal proportion. Correct. Even this is not true for, you see, the other examples also. Okay, that's why it is not that important. It was there, so I've given you. Okay, these are the laws we have by which the atoms combines together and forms different compounds, right? So based on this, we'll see few questions now. Okay, just let me show you. Okay, now you see this. First of all, you solve question number mm, first of all, you solve question number 4. Is it option A? All of you are getting option A? Okay. So first one, your answer is correct. It is option A. It says what? The percentage of copper and oxygen in sample this is obtained by different methods were found to be same. This illustrates constant proportion. The definition is that only. Correct. Now you solve this question. Question number 1 you do. Question number 3. Question number 5. One by one you do. Question number 12, 13. You first do all 1, 3, 5, 12, 13 and send the answer in a one shot, single shot. Okay, 1A, 2B, like that you said. so that we can avoid any confusion. Okay, all of you. Solve all first and then send the answer. Okay, so 1 is A, 3 is C, 5 is C, 12 is B, 13 is A. Achha, just a second, I'm just removing this. Fine now. All of you done? Okay, so I got the response of Pradyun, Anusha, Oro. What were others? Ansh, Kshitiz. Okay, let me check Kshitiz once. Oh yeah, it's on the. Yeah, Kshitiz, I received that also. Okay, fine. Let's do it. Uh, First of all, the first question: which of the following pairs of substance illustrate the law of multiple proportion? Law of multiple proportion means what? One element combines with different masses of the other element, right? So it is obviously true for the first option, that is CO and O2. Any confusion in this? No. Question number 3. Among the following pairs of compounds, the one that illustrates the law of multiple proportion. Law of multiple proportion is what? One same mass of one element combines with different mass of the other element, right? So nitrogen, the mass is what? Nitrogen, the mass is 14, 14 here. When HCl forms, so this is not true. This is not true. 32, 32. So it is 32 here and 2. So H2O when it forms, so H2O when it forms, so it is 2 × 61:8. And here it is 32 and 4. It is also not true. 16, 16, 63.5, 2 × 63.5. I think in this one, option C is correct. That is what you are getting. Here, option C. 1:2 ratio is there. This is not possible. This is also not possible. Carbon and this is also not possible at all because we have different elements. Right. So option C is correct in question number 3. Question number 5, to sample which one, Shitish? Third one. Okay. Third one. NH3 and Cl3, correct? NH3, nitrogen is 14 and this is 3 gram. Okay, again NCl3, nitrogen is 14 and this is 3 × 35.5 gram. Law of multiple proportion suggests what? If two elements combines to form more than one compound. Here we have 3 elements, Shitish. Nitrogen, hydrogen and chlorine. Here also we have hydrogen, sulfur and oxygen. So A, B, D are not correct because of the same reason. Multiple proportion, we have 2 elements combines to form different compounds. Correct? Okay. Oh, I'm sorry. So we're talking about 5th, 20, 12 and 3rd. Else we have done, right? This is answer A. Third one answer C. Fourth one answer A. Okay. Now 5th one is the sample of lead oxide were separately reduced to metallic lead. Okay. Correct. So we are getting lead from PbO. We are getting Pb. By heating in a current of hydrogen, the wedge of lead from one oxide was half the weight of lead obtained from the other oxide. The data illustrates. Okay, let me just go through the question again. Okay. So basically we have 2 different oxides, no? We can have various oxides of lead possible, PbO2 possible, even we can have Pb2O3 also possible. So it says what? That 2 sample of lead oxide, we do not know what is the formula of lead oxide we have. Yeah, right, Pradyum. So we do not know what formula of lead we have, but it says what? 2 sample of lead oxide were separately reduced to metallic lead by heating in a current of hydrogen. So any 2 oxide is, reacts with hydrogen and forms the metallic lead. The weight of lead from one oxide was half the weight of lead obtained from the other oxide. The data illustrates. Okay, obviously when we have 2 different oxides of same element, obviously it gives the law of multiple proportion because these obeys the law of multiple proportion. Correct? Question number 12. N gram of substance X reacts with n gram of substance Y. Okay? So X plus Y. This is the reaction, and this gives P gram of R and Q gram of S. So what is the data given? You see, for X it is n gram,
it is n gram, and for Y it is m gram, for R it is p gram, and for S it is q gram. So which law will apply? We'll have law of conservation of mass. So what we can write, m plus n is equals to p plus q, and this is true for m plus n is equals to p plus q. So answer for this is what? The 12th one is B. Law of conservation of mass. Okay, the mass of reactant is equals to the mass of product. Okay, which of the following is the best example of law of conservation of mass? What is the answer? Tell me. 12 gram of carbon combines with 32 gram of oxygen, so it is 44, and 44 gram of CO2. Obviously first option is correct. Let's check the another options also. So 13th one, first option is correct. When 12 gram of carbon is heated in a vacuum, no change in mass. Okay, a sample of air increases in volume when heated at constant pressure, but its mass remains unaltered. That is also, it is not a chemical reaction. It is also not a chemical reaction. The weight of a piece of platinum is same before and after heating in air. The weight of a piece of platinum is same before and after heating of air. It means this also does not follow the law of conservation of mass. Could you tell me question number 6? Question number 6 and question number 15. Question number 6 is C and 15 is we'll get a break now. We'll take a break now. Just a second. Just let me finish this. Just two questions. Question number 6 is C. You are getting chemical equation balanced according to the law of conservation of mass. That's fine. 6 is C. That's correct. Okay. Question number 15 is what? Compound A, mass is given. In a compound A, mass of nitrogen is given and this gram of oxygen. Compound B, oxygen, nitrogen is this, oxygen is this. The compound C, 3 gram of nitrogen and this gram of oxygen. This results obey the law of, what is the answer, 15th one? Fifteenth one is B, is correct. Yes, it is multiple proportion. It's B. Correct. A and B combines and it forms C. So answer for 15th one is option B. It is option C. Okay. Did you understand this? Correct. Fine, guys. So we'll take a break now. Yeah, we'll take a break now. It's 6:40 almost. So we'll start at 6:55. Okay, 6:55. Fine, take a break, guys. Okay, guys, welcome back. Can you hear me? Yeah. So all of you understood that with the various law of combination, correct? Okay, fine, correct. Now we'll see the next topic in this. Okay, so far we have discussed about atoms. We have also discussed about how atoms combines and forms molecules and the various law of the combination of atoms. Okay. Now, if you have to find out the mass of an atom, then what we need to do? How do we find out the mass of an atom? Okay. So we are going to define a term here, which we call it as atomic mass unit. What is this term? Atomic mass unit. Anybody has any idea regarding this term? Okay. No, see, it's very simple. No, just let it be. Represented by U is fine. Okay. So it's very simple. You see, as the term suggests, atomic mass unit means it is a unit of what? Unit of atomic mass, right? We define this term as, we represent this term as AMU in short, or simply U. Both are the representation of atomic mass unit. Okay. Unit of atomic mass. Since we are talking about mass here, mass of an atom, right? So this must be the unit of the mass, correct? Correct. So whatever the unit is, it is the unit of mass, and we already have the another unit of mass. For example, we have gram, we have kilogram, we have milligram, etc. Right? We have another units of mass. So first thing, we already have these units. Then why do we need one other units for mass? That's the first genuine question. Right? Second thing is what? Since we have defined AMU, atomic mass unit, so like the other units of mass have some relation. What relation? 1 kg is equals to what? 1000 gram. Right. Similarly, atomic mass unit AMU should also have relation with gram, kilogram, or milligram. Did you get this? Did you understand this point? The 2 points I said. First, why do we need this particular one specific units, right, for atoms? And second, the relation of AMU and various other units of mass, correct? Now the point is, you see, atoms are very tiny particle, right? Very tiny particle. You cannot even imagine. You see, the atoms are those particle which cannot, you know, divide further. We cannot say, because that is again wrong definition of atoms we have. Now suppose if you have some object into your hand, and if you want to break it down into small pieces, right? So the smallest piece, or the, with your own capacity, whatever the small piece that you are getting, which you are not able to divide further, we can divide it by other methods, but physically it is not possible to divide those atoms, those particles further. That small particle, you can take that as one atom. Just for reference, to make you understand, I'm taking this example. Okay. So those particles, you see, those tiny particles, if I ask you to find out the mass of this, right? It is very difficult to find out the mass of those small particles because of their size, correct? And their mass will also be very small, almost negligible, you can say, right? So for that mass, if you have to present in terms of represent in terms of gram or kg, that will be a huge number, right? Not huge value, huge number, right? And it is very difficult to maintain that database with that large number. Okay, value is very small, but the number will be large, right? It means, suppose you have some value like electron, the mass is what? Mass of electron 9.1 into 10 to the power minus 31 kg. You see in kg, this value is this, right? So that's why we have given, since the particles are very small, that's why we have given a new unit to these mass, to these atomic mass, and that unit is atomic mass unit. That is a requirement of this new unit of atomic mass, correct? Now, how do we define this? What is AMU? So write down the definition here. Write down, it is the quantity equal to, it is a quantity equals to 1 by 12th mass of 1 by 12th mass of a carbon 12 atom. Right? So how do we define 1 AMU? 1 AMU is equals to 1 by 12th mass of C12 atom. Carbon 12 is the isotope we are considering here, not 13 and 14, because C12 presents in maximum amount, abundance, right? That's why we are taking C12. Why carbon? Because carbon is present everywhere. So with respect to carbon, we can define this easily, right? Now this value, the mass of C12 atom, is experimentally observed, find out, and that value is coming out to be 1.9924 into 10 to the power minus 23 gram. Minus 23 gram. This is the mass of C12. It is experimentally determined. What, Ansh, I didn't get you? Yes, Ansh, I didn't get you. Tell me. Acha, 1 AMU mass of 1. See, first of all, it is a definition of AMU. Why we are not using its one proteum? The reason may be, the atoms, different atoms have different number of protons. Then you can say, sir, we can multiply the number of protons with the mass of one proteum atom, right? But along with proton, in the nucleus, we have neutrons also present, right? So you can find out the mass that is contributed by the protons if you assume this, correct? But neutron, how do you take care of that? Okay, so one proteum atom if you are taking, then we can probably define the mass of those atoms in which we have only protons present. Those are only few. We have one hydrogen atom there, like that, right? So that's why we have defined this way. Now, this is something which is beyond our scope of discussion here, right? There are various different mass spectroscopy is a method, okay, mass spectroscopy that will study in maybe in BTech or PhD. If you do, will study over there. But there are methods we can use. Some, some radiations we can use, mass spectroscopy we can use, right? So there are various methods we can use this to find out the mass of a C12 atom. Okay, that is not in the syllabus, not in the graduation also. In graduation maybe you'll get, okay, but not in that detail also. So that's a different thing, right? Mass spectroscopy is a device actually that we use. There is a device for this particular experiment which we use to find out the mass of that. Okay, so let's not go there. Okay, fine. So 1 AMU is defined as 1 by 12 mass of C12 atom. Why carbon? We are see actually excuse me. See, for one, you can also ask me, sir, we can calculate the mass of carbon. Then we can also calculate the mass of other atoms also like this. Why we are defining AMU and then relation with this and then other elements, we are finding it out, right? So the point is this experimental method is very complex. It's very difficult to find out. There are a huge number of atoms, right? And the method is very complex. So to avoid this calculation, what we have done, we have calculated for one, that is carbon, and with respect to that, we are calculating the atomic mass of other this thing, the other elements, right? So that's how we define AMU, and later on we'll define atomic mass also according to that, with the help of carbon only. So we'll see that later after this. But here, if you solve this, you'll get 1 by 12 into 1.9924 10 to the power minus 23. So 1 AMU, when you solve this, you'll get, like I said already, that this AMU and the unit of mass, the other units of mass, will definitely have some relation, and that relation is 1.66 into 10 to the power minus 24 gram. This is the relation of AMU, which is the unit of atomic mass, and the mass unit is gram. Copy this down. Okay. Now, if I ask you the actual mass of an atom, suppose hydrogen, right? So hydrogen, the actual mass, oh, I'll write down here, should be equals to the atomic mass in AMU into this AMU. Since 1 AMU is equals to this gram, so we convert this into gram. So actual mass of one atom, one single atom, is this atomic mass into this converts into this. So this in AMU into this, the whole term you'll get in gram. Okay, because 1 AMU is equals to this many grams, so these many AMUs come in gram. So hydrogen, the actual mass will be what? 1 AMU. So 1.008 is the exact value of this into 1.66 into 10 to the power minus 24 gram. So its actual mass is 1.67 into 10 to the power minus 24 gram. You see how less the value is. 10 to the power minus 24, the order we are getting. Clear? Done? Copied? Finished. One electron, the mass, if you ask me, the mass is 9.1 into 10 to the power minus 31 kg. You can convert this into AMU, because this into, or if I write on 1.9.1 10 to the power minus 28 gram, right, this gram is equals to 1 AMU. So this divided by 1.66 into 10 to the power minus 24 AMU. So one electron is equals to this AMU. You can solve this, you'll get. You know the mass of one proton. The mass of one proton is equals to 1.697 into 10 to the power minus 27 kg. Okay. Now you convert this into gram. What happens? 1.697 into 10 to the power minus 24 gram, which is almost equal. You see 1.66, 1.69 we are getting. Almost equal. You can find out the relation by this. Got it, Ansh? So this divided by 1.66 into 10 to the power minus 24 gives you the mass of proton in AMU. Okay, fine. The next term we have to understand here is the relative atomic mass. Relative atomic mass. In short, we call it as RAM. Now, how do we define this? Again, I have explained this concept to you, that to find out the mass of one atom is very difficult. That's why we have calculated the mass of one particular atom, that is carbon, and we are trying to find out the atomic mass of other element with respect to carbon. So we are calculating the atomic mass with respect to carbon, hence it is relative atomic mass. Correct? So how do we define RAM, you see? Relative atomic mass, RAM, is defined as the mass of one atom, means the atom which RAM you have to find out, the mass of that particular atom, mass of one atom, mass of one atom of the element, that element we do not know, this whole divided by 1 by 12 mass of C12 atom, which is nothing but 1 AMU. Okay, if you see this particular expression that we have here, this divided by 1 AMU, right? So it means mass of one atom of any element, if you divide that by 1 AMU, you'll get the relative atomic mass. Okay, Now, how to find out this? First of all, you should know two, three things here, that the mass of proton and the mass of neutron is equal. And we are assuming this as M, right? Mass of proton and neutron is equal. We are assuming this as M, right? Another thing, suppose we are assuming an atom for which we need to find out the relative atomic mass. So that atom is, suppose this, right? Suppose this atom we are assuming. And we know in the nucleus, what all subatomic particles present? Could you tell me? In the nucleus, what all subatomic particles are present? Proton and neutron, correct. So we have proton plus neutron here. So since the element is not mentioned here, since the element is not mentioned, then we do not know the number of protons and neutrons. What is the number of protons and neutrons for C12 atom? Can you tell me? The number of protons and neutrons for C12 atom? 6 and 6. Very good. Number of protons and neutrons for 12 atom is 6 and 6. This element is not mentioned here. Then what we do, we assume the number of protons in the nucleus is Np, and the number of neutrons in the nucleus is Nn. Why we have to assume? Because this element is not mentioned. We are trying to find out a general formula, right? If element is mentioned, like in case of carbon, we know the number of proton and neutron. And we know the mass of an atom is concentrated in the nucleus. Yes or no, guys? The mass of an atom is concentrated in the nucleus. Yes or no? Right? So what we say, if you find out the mass of the nucleus, that would be the mass of the atom, correct? Because atom is what? Atom is hollow. Only the nucleus, we have a small region where the mass is concentrated. So that small region is nucleus we are talking about, right? So if you are able to find out the mass of the nucleus, correct, mass of the nucleus, that would be the mass of the atom. You understood the idea? Correct? Yes. Now to find out the mass of the nucleus, we should know the mass of the proton in the nucleus plus mass of the neutron in the nucleus. Since in the nucleus we have only protons and neutrons, so if you know the total mass of protons present in the nucleus plus total mass of neutrons present in the nucleus, the sum of that would be the mass of the proton. Sorry, mass of the atom. Is correct? Right? Clear? Yeah. So now you see, if I ask you, what is the mass of protons we have here? Mass of proton, could you tell me? Mass of proton, it is what? M into Np, very good. Very good, Ansh. Because M is the mass of one proton and there are Np such protons we have. So it is M into Np. Similarly, mass of the neutron, tell me guys. Mass of the neutron is what? Mass of the neutron is M into Nn. M into Nn. Correct? So total mass would be what? The sum of the two. That will be M into Np plus Nn. Any doubt? Any doubt in this? No. Very good. So if I write down the mass of C12 atom, this is for the element that we do not know in the numerator. The mass of C12 atom is what? Is again the mass of proton into neutron plus Np plus Nn. But we know this Np and Nn value for carbon, that is 6. Every step I'm writing down, see this. So you're getting 12 m of it. Is it clear, guys? Any doubt in this? Please respond, all of you. Please respond, all of you. Any doubt in this till here? If you understood this, it's fine. We are done almost. Right, correct. Yeah. Now what we do, we'll substitute this in the numerator, sorry, in the denominator. We'll substitute this total mass, this, in the numerator. And just we'll solve it. Correct? So RAM, the formula of relative atomic mass, it becomes RAM is equals to the mass of proton and neutron Np plus Nn for that particular element divided by 1 by 12 mass of C12 atom, which is 12m. Now when you solve this, you'll get Np plus Nn, because all other terms gets cancelled here. Mass gets cancelled, this gets cancelled. Np plus Nn, it becomes what? The relative atomic mass for any element. This sum, we call it as the total number of nucleons. Total number of nucleons. The number of protons plus the number of neutrons is the number of nucleons. Okay. So relative atomic mass, the formula becomes is equals to the total number of nucleons. This is the formula we get. Any doubt in this? All of you? No doubt. Correct. Right. So basically, see the terms here, relative atomic mass. It looks like mass, but this is not a mass, it's a number. Right. There is no unit for this. Right. Try to understand this. Mass term got cancelled over here. So there is no unit over here. You must keep this in mind. There is no unit. However, the term is relative atomic mass, but the unit is not of mass over here, just a number. So if I ask you, what is the RAM, relative atomic mass, for oxygen, for nitrogen, for carbon? (16, 14, 12). Just we add what? Just we add the number of protons plus number of neutrons. So we have 8 protons and 8 neutrons in carbon, in oxygen. So it is 16, it is 14, it is 12. Okay. Again, you see, it's just a number. There's no unit over here. You must keep this in mind. The term is relative atomic mass, but unit is not there. Okay, this is one thing. Directly they'll ask question from this, nothing much we have here. Okay, there's one more term that we calculate, that is average atomic mass. Average atomic mass. Hello? Average atomic mass. Correct. So average atomic mass is what? It is because of the various isotopes that we have. Suppose, for chlorine, right? So when you take a chlorine element, right? Chlorine element, if you take a sample of chlorine element, if you collect it, you will get 2 different types of chlorine atom here. One is we have chlorine 35 mass number. Another one is chlorine 37, the mass number. Chlorine 35 and chlorine 37, the mass number. Correct? If you take a sample of chlorine, you'll get 2 types of isotopes for this. Like we have for a carbon, C12, C13, C14, like that. Okay. Carbon also, if you pick, here also we have three types of carbon atom you'll get. You'll get C12, C13, C40. But the atomic mass of carbon we consider as 12 because this part, the C12 part, is almost present 99.89%, something like that. So it is almost 100%. That's why the atomic mass of carbon we consider 12 only for this. But here it is not like that. Here the chlorine 35, the mass number that you have here, this atom of chlorine, the percentage abundance of this is 76% in the sample. And rest is this 24%. That's why you see, what is the atomic mass of chlorine? Could you tell me? What is the atomic mass of chlorine? 35.5. Why it is 35.5? The reason is this only. Because we have two different isotopes of it. The value is the should be in between of these two. Since the composition of this 35 is more, hence it is closer to 35. That's what you are getting here. So how do we find out the atomic mass of this kind of sample where we have different isotopes present? That we call it as average atomic mass. So just we have a formula here, and that formula is average atomic mass is equals to, we'll write x by 100 into A plus y by 100 into B. Now this is what this x and y are the percentage abundance. Write down. We have two isotopes of atomic mass A and B. This is the atomic mass A and B. This is also the atomic mass. And the one which has B atomic mass, its percentage abundance is Y. And A, the percentage abundance is X. So this is the formula. So write down X and Y are the respective percentage abundance, right? So with this formula, if you find out the average atomic mass of chlorine, that would be 76 by 100 into 35 plus 24 by 100 into 37. Could you tell me the value here? It is 35.48, which is approximately 35.5. And what is the unit? 35.5 AMU. It's not gram again, because this 35 and 37 are AMUs, not gram. Then also we can write, suppose Z by 100 into C. Just we keep on adding them, Z by 100 into C and so on. Rubab, understood? Right? We will keep on adding them. Is it clear? Is it clear, guys? All of you understood? Yes, we can say that. We'll just add all the isotopes and its percentage abundance will multiply, divide by 100, and we'll add them up. That gives you the average atomic mass. Okay, guys, fine. So we are done for the session today. Right, we have to start with the concept of moles next class. Okay, concept of moles next class we have to start. Correct. So that we'll see from the next class. Okay, thank you so much. Take care. Bye bye.